All right, let's see here. Why can I not? Here we go. Yo, yo, yo. Let me bump the volume just a bit here and make sure my sound is coming through the right microphone. All right. What up, Alcaeus? How we doing? Let's, so we want to do a couple things this morning. I think the first is we're going to see if somebody's wrong on the internet about TypeScript. Trying to wake up. All right, there is a Twitter thread about the age-old debate of return types, annotating return types versus not. And I want to take a look at this. It's this thread. All right, give me a link to the code. Okay. So what is the point of this? Let's see if we can pick this out here. I don't want to use that. I don't know what this is trying to show me. Good morning. All right. No, I went too far back again. Just give me the code. The simple code. Get rid of this. Okay. Yeah, okay. So that, he's saying the problem right here is that this is any. One, rule that out. I don't understand. I think this is a bad argument. annotating get users with a return type of unknown. It's I don't understand what the point of this is. What up, Priv? All right, so I'm not sure what this is trying to prove. Whatever, I don't care. All right, I want to write a. Let me see, used to me. Oh, chat. I have a Twitter poll up that I would love for you guys to vote in. Have you, or do you, I should say, use Git work trees, or have you not heard of them? All right, I want to write a conference CFP for Caroline and Code Conference. And let's log in here. I probably already have a login, but we'll find out. What? Is it twice? No, it's not. There we go. Can I log in with GitHub? Okay, I must have logged in with Google. All right, so I have a submission for Riot already. Let's see here. We're gonna use ChatGPT to help us write this. Write a description for a conference talk that introduces the new programming language, Gleam. You may go search the Gleam website for more information. The talk title will be in the talk, I want to introduce Gleam by showing a case study on a Twitch SDK client I built with it. GPT-4 is fine. I don't know. I might switch over to Claude. I use ChatGPT-4 for writing tests a lot. It's very good at writing tests if you give it a test suite that you teach it how to write a good test suite. Perfect. That's literally perfect. Perfect, perfect, perfect. I'm gonna come throw this in a notes doc. That's a lie. We can make this and we'll say Gleam comp talk. Okay, we'll just dump that there. We'll come back over here. The ever-evolving landscape of programming languages, finding in languages with balanced safe, challenging. Talk format, full session, audience level, we'll say intermediate, category is development. Wow, this auto, I don't think it's even in here, Gleam. So we'll put, we'll say Erlang, and we'll say Elixir, and we'll say JavaScript and TypeScript. And enter Gleam. A new sister language to Elixir that is no, we don't need that bit. I installed Gleam with Nix priv, so sounds like a skill issue. We'll dive into with Erlang and Elixir. It seems and its ability to compile to JavaScript with alright, that looks good. OTP. I don't want to put in any of these. That's good. All right. Let me come dump this into my notes doc. Boop. And we'll submit that. There we go. All right. We have 2 talks submitted to Carolina Code Conference. It will probably be recorded. What up, Trash Puppy? I'm totally gonna redeem code review on NetPuppy. Hell yeah. I would be so down. In fact, you can save your points. And I'll just do it. You let me know, Trash Puppy, let me know when you want me to read through your code, and I'll do it on stream one morning. Freaking glasses. Okay, so trying to think about what I want to do right now. If we want to dive back into bit of a lame question, not a lame question, but any regrets on those XM4s? Not a single one. I love my XM4s. They're so good. The only thing that's annoying is sometimes they don't do great when multiple devices switch between them, but that's like most Bluetooth, so I don't really mind. But like overall, the quality of them is amazing. Highly recommend. So I'm going to start a video series on YouTube going through the chapters of this book, Melange for React Devs. And I'm trying to debate about when I want to record this. Maybe we just do this. No, so Melange is a compiler that compiles OCaml and ReasonML with JavaScript. I spent like 2 months on stream building this tool, John, which helps you get started. Maybe we record chapter 1 today. All right, let's actually do it. Let's get set up here. And we're gonna record video 1 so Kyle can start putting out some content for us. This won't take very long. This will be like a 10-minute video tops probably. So let's go ahead and we'll go to, do we need any of these? We can close that. Close that. We can close that. And we can close that. We'll just do it in this screen, I guess. Actually, we'll just make a new session. We'll say new session, and we'll call it React Melange for React Devs. Melange for React Devs. What? Is that not the right? Oh, I definitely did not get that command right. So it's got to be new -s Melange for React Devs. There we go. Okay, so let's go to personal. And we're going to clear that, and we're going to make a dir, and we're going to say Melange for React Devs. Change into that. Do a little get init in here. and we're gonna come over here. All right. So we're gonna start the video. We're gonna introduce what Melange is, introduce Melange for React developers, then dive into the intro, read through this page. We'll go to installation, and I should probably make sure OCaml is working on my machine. Let's go ahead and well, what's this say to do? That's setting up our switch. Okay, nothing crazy there. All right, let's make sure we can get a Nix shell, Nix packages, and we need OPAM. Yeah, we need those. And then we also want probably bun, or we'll take node just for the example. No, let's take bun, fuck it. Well, let me see the examples. We should probably follow it how Nix node. So there's just like a Node.js latest. Yeah. We'll take that one. And we'll throw that there. Let's get our shell loaded with that stuff while we're waiting. All right, so we go into counter. You've already installed the starter project, so this doesn't have... All right, let's go look at the starter project, because we should probably follow... Nice. All right, we'll want to talk about that. Doesn't this script... Oh, this is clever. I've never seen anyone do this. Okay. So do I have OPAM? Right. I guess I need to do this. We'll just do this the easy way. Nix packages, and then this will be Nix packages that, and we'll get rid of this comma, and this will be Nix packages that. Oh, so it's like comments, what happens? Nothing happens. It's literally just a way of commenting JSON, since JSON doesn't support comments out of the box. System arch 64-Darwin. Maybe we'll do multiple chapters today. All right, so now we should have node in our shell. Great, and opam switch list. Do I have any switches? Let's can I uninstall opam? All right, what are the instructions here? Opam init. Maybe I can run that. Let's see what happens if we do that. Opam init -s reinit. Does this example have a OCaml format? It does not. Does the Dune project list OCaml? No. Okay. So we're gonna have to install OCaml format and all right, so we'll go through installation. We'll get through that. We'll do these steps here. We'll get OCaml format and OCaml LSP installed. Then we'll come and we'll do chapter 1, which is making a counter. Okay, we have some solutions. We have some problems at the end. Cool, that's good engaging. And then we have chapter 2, which is numeric types. All right, let's see what he calls the chapters. Yeah, okay. Okay, so maybe we do like the first 3 chapters because they seem pretty easy. We'll do intro and installation as one video. Let's plan this out here. I want these to be short, like little clips. So we'll say melange for React devs, and we'll say video 1 will be intro plus setup. Video 2 will be chapter 1, which is counter. Video 3, chapter 2, numeric types. And maybe video 4, we'll see how we're feeling after we record those 3, because that's going to be really easy to do. Chapter 3, which is Celsius converter. All right. Let me put out a tweet quick. X.com. OCaml, Gleam, and coffee. We're recording a few videos for a YouTube series on walking through Melange for React developers. Each chapter of, and then diving back into our Gleam Twitch client. Twitch.tv/DMMulroy. All right. Let's see here. We're gonna go there. We don't need you. Move you over here. Okay. So opam switch list. Clear. And let's go back to our installation. All right, I've got a good sense of what we want to do here. Let me move this. And let's say, actually we can go up a directory and we can remove Melange for React devs because we're just going to clone the repo. Let's just say this will be M4. Cool. Now let's rename that. Just send in. Okay. So let's start here. And so in video one, we want to cover what is Melange. And why should you care? Show, what do we want to show in the main site? Then we're gonna cover the book. Okay. Touch on JSX being built into Reason ML. Camel plus Reason. Intro. Which this is going to be called Melange for React devs. Okay. And so Melange is OCaml. The stream title is going to be wrong for about an hour, but that's okay. Because I don't feel like changing it. Okay. So let me mark this. Marker, and this will be video one. Intro to Melange plus Melange for React devs. All right, let's kill the music. I might make a duplicate scene here. Or do we leave Twitch chat up during the video? Should we leave Twitch chat up during the video, or should I change the scene where I just move myself vertical? I hide chat and center myself in this like little well on the right. Because we could do, I don't know, I think we behave. All right, well, we'll keep you guys. All right, let's just wing it. We're gonna go for it. Worst case, we can always, let's make that full screen. And again, I just wanna get my, so we can click through there, get started, installation. Okay. All right, I'm gonna pause music while we record this, and I guess I can update the title. Recording a series on React Melange. Recording a series on Melange for React developers. OCaml. Whatever, we don't need to change it. I don't care. Okay, so we have to turn off alerts for sure. All right, let's go for it. How do we want to do the intro? I guess like introduce myself a little bit and then introduce Melange. Whatever, I'm just gonna wing it and see where it goes. Do it live, as Coppinger says. So let's, yep. Let me make a marker for Kyle. Do that. And all right, let's get ready here. Priv, I'll get to you after I record this first video. All right, how do I want to start? Let's see here. Let me pull up my notes. Hi y'all, my name is Dylan Mulroy. I have been a software engineer for the better part of 10 years professionally. In the past year and a half, I've been really getting into OCaml, ReasonML, and functional programming more broadly. And one of the technologies that I found that I've really enjoyed building applications with is a tool called Melange. Melange is a compiler which will take OCaml or ReasonML and compile it to JavaScript. If you're not familiar with what OCaml and ReasonML are, they are functional programming languages. ReasonML is a alternative syntax for OCaml, so they can kind of interop seamlessly in the same project. So what you're looking at right here for video 1 is going to be just a quick intro to Melange and getting set up. We're going to be walking through each chapter of this book titled Melange for React developers. It's a project-based guided introduction to Melange for React developers, and it's a free book online. Link will be in the description to check this out, and the code is also on YouTube. If you're looking for resources for Melange and like why you may want to use it and how to use it, you can find that at melange.re. So let's dive into getting started. So in video 1, we're going to cover the basics of the book and getting started. So let's follow along. Get started. Intro. So this book is still a work in progress. We're going to be making videos as the author of this book publishes chapters. We already have a handful of chapters to get through, so look forward to those videos. We're going to try to have a video for essentially each of these sections in the sidebar. So up first is the intro. Motivation. This is a project-based guided introduction to Melange and its ecosystem. Because Melange uses both OCaml and JavaScript ecosystems, there are quite a few tools and concepts to learn. Therefore, we try to make each chapter small and digestible, not introducing too many things at once. Audience. You should already know how to make front-end applications in JavaScript, in particular with React. You should be interested in learning how to leverage your existing knowledge to build apps using Reason React. You do not need to know OCaml. We'll slowly introduce the basics of the language throughout the tutorial. That said, a good complement to this guide is OCaml programming, correct, efficient, and beautiful, which teaches the language from the ground up and goes much deeper into its features. Just as an aside, this resource here is the resource that I use to learn OCaml, and it's definitely among the top resources for learning the language. Link will also be in the description for this book. So chapters and topics. So chapter 1 is the titled Counter. We're going to build an app that has a number that can be incremented or decremented, and it will cover the modules, options, React string, pipes, pipe blast operator, functional chaining, and the switch expression. Now, I'm not going to read through all these. We'll cover the section that we're going to cover in each video at the beginning from this table, but let's move forward. Because of the focus on Reason React, we won't cover traditional OCaml syntax in this guide. Instead, we'll cover the Reason syntax, which works great with Reason React. So just a little bit of background on Reason. As I mentioned, ReasonML is literally just an alternative syntax to OCaml that feels more like JavaScript and is meant for people coming from C family languages like JavaScript. It was made by Jordan Walk, who is also the creator of React. So this next bit might be unsurprising, but Reason has first-class support for JSX built into the language, which is why it lends itself so nicely to React development. So let's jump into installation. So I already have OCaml installed in my system, but we will still walk through these steps here. The first thing we're going to need to do is install OPAM. OPAM is OCaml's package manager. This is how we go out and install packages similar to NPM. So follow these instructions here to get started, and then just keep walking through here, and then we're going to download and clone the repo. One thing to note is that installing OPAM for the first time may take a few minutes, just as a heads up. Another thing to add is OPAM has this concept of switches. You can kind of think of switches as really local dependencies for your OCaml project on a per project basis. You can kind of think of it like node modules, but where all of the dependencies in your switch are compiled with a specific version of the OCaml compiler. All right, let's go and download this project. So we'll do git clone. Oh, looks like I copied that bit. and we don't need the CD. Clone that in, and then we'll go into Melange for React developers. And in here, we're going to make a new switch. So let's do eval opam env. This is a command you're going to get used to running often. So what this does is it's going to put some environment variables into your path that will make working with OCaml scoped to the current project you're in. So we're actually going to come in and switch create, and we're going to use the most recent version of the compiler, deps only -- yes. So this is going to bootstrap our new switch for our project. And we're going to give that a few minutes to install. This will probably take anywhere from 3 to 5 minutes the first time you run it or when you set up new switches. All right, Kyle, I'm going to pause and wait for this so you can cut this till when this is done. And I'm going to jump back to chat until this is done. What up, low-level learning? Holy fuck. Yeah, dude, I don't think you saw the comment on your screen yesterday, but I was asking if your switches were Glorious Pandas because your keyboard sounds very similar to mine. Y'all, if you're not following Low Level Learning, you 100% should be. He produces some of my favorite technical content right now. I do not have a very strong background in low-level stuff, especially around C and like assembly instructions, and he creates just super, super stellar content on both YouTube and Twitch. And he also, I believe, has a course, which is on my to-do list for learning C. All right, I'm gonna turn the music back on because this silence is deafening right now until the switch gets done installing. Oh man, I can't wait until OCaml has a relocatable compiler and this isn't so painful. The length of time it takes to set up OCaml is probably one of the biggest detriments to it being super friendly to new people. Yeah, also chat, Low Level put out a bunch of good content in the past week on the backdoor bug that was in XZ or CX. I don't even remember, whatever the compression algorithm library was. And it was really good, really informative. That's where I basically learned everything that went down. Also, thank you for the follow, Ma Codes. Super appreciate you hanging out. XZ, yeah. Yeah, it is crazy wild. And like, it makes you sit back. Like, yeah, see you, man. Have a great day. Like, it really makes you think about like all, like, especially in like the node ecosystem, right? Think about like all the dependencies we install in our projects that have nested dependencies and all of those dependencies that have post install scripts. Like, it's a scary thought about like how easy, maybe not how easy, but how vulnerable our systems are to kind of attacks like that. Okay, we're gonna pick back up as soon as it spits me out. All right, let me pause the music. Okay, so our switch has finished setting up, and we can see that in my command line. So if we go ahead and we're gonna get, like I mentioned earlier, we're gonna get real used to running this command right here, eval opam env, which is basically telling OCaml, hey, scope all the OCaml tools to this specific project and the compiler version that this project was built with. So let's run that. Bada bing, bada boom. Let's clear and let's see what we're working with here. So we have this nice package. One thing is to call out in the getting started instructions is that if you're following along and using VS Code, you're going to want to install the OCaml platform tools and set up these settings in VS Code. I'm going to be following along in NeoVim, and rather than installing the OCaml platform extension, we are going to install the formatter and the LSP server ourselves. So to do that, we're going to say opam install, and we're going to grab OCaml LSP server and OCaml format. So we'll just run that command there. And this will take a minute to run through. And we're going to turn the music back on while that runs. Kyle, again, we'll just cut to when this is done. What up, Nightshade? Can we get through that? And then this will be a second video. All right, what does npm init do? Oh shit, I fucked up here. Okay, I see where we fucked up here. We're just gonna let this install so we get this stuff cached. Kyle, we're gonna cut back to where I talk about installing the project with OPAM. In fact, we should probably cut the whole way back to like cloning the repo. Because I straight up did not follow the instructions. All right, we're just gonna do this, changed up. So let's do that. All right. All right, Kyle, we're gonna pick back up here from, basically you can start after I talk about that I already have OPAM installed on my system. Let's pause the music. Scroll down. Okay. Okay, so getting started. Let's download and run the starter project. So we'll go to GitHub to where this project lives. This is the repo we're going to be following along with. So let's go ahead and clone this. We'll grab that link. We're going to come over here and we'll say, do we already have that? Say git clone. Copy that into Melange for React devs. We're going to change directory in there. Let's take a look what we have in this directory. Okay, our standard stuff, and then our instructions. We're going to run npm run init, so let's go ahead and run that. Let's actually eval opam env. Make sure we are working with the right OCaml environment, and then let's run npm run init. So what this is doing for us, this is running opam switch create, and let's scroll back up here quick. Opam switch create in the current directory, a project using the compiler version 5.1.1, which is the current release. We're going to say yes to all the prompts, and then we're going to install dependencies only. This part's a little confusing, not super important. It just means that we don't want to install our project itself, just the dependencies we need to build and work on the project. So this is going to take a few minutes to run the first time, so we will be right back when this is done. Okay, that's better. I should have just followed the instructions the first time. Man, this is painful. Let's go explore the project while that's loading. So what do we have? We have an index.re. Yep, I know that's not working. Cool, okay. Do we have the font size in 24? Great. Come on, OCaml, I believe. Four hours later. Oh my God. Don't you dare call the Postal Service elevator music. I love the Postal Service. Postal Service is so good. One Bite, are you coming to Asheville? When we all go? Badger, you're going to Asheville, right? Sick. All right, let's pause this and jump back in. Tim T, this isn't representative of, oh, is this still going here? I guess it is. This isn't representative of OCaml's compile times. This is just bootstrapping a new project. OCaml compiles actually very, very quickly and very fast. It's just like the initial setup of a new switch is painful for a couple of reasons, but yeah, once it's installed, you don't have to sit through this long process again. Looking probably camp, but not completely, trying to figure out a schedule. Well, cool. Either way, I'm stoked that we'll be able to hang out and you visit Raleigh, so that'll be fun. I'll probably be able to come to your buddy's gig too, so. Oh my God, I thought this was done. We're gonna shut the door so we don't have to deal with that. Hey, no barks or you go in timeout, Winnie. Oh my God, this is so long. My fiance is coming along too, but she's going to have actual fun. We all do nerd shit. Nice. I don't think Justine is coming along. Maybe she is. I don't know. I'll have to check. I don't think she is because we'd have to bring the dogs and someone would have to watch them. But I'm basically getting back from Canada and then driving to Asheville. It is, so the way, yeah, you're right, Tinty. That is what's happening. We don't have a relocatable compiler, which basically means when you install a dependency, you have to compile it, because we don't have any like build artifacts or binaries hosted anywhere. This is basically going out to GitHub, cloning all of these repos, and then building them which is why this takes so freaking long. In a future world, most things don't have binary artifacts, though, do they? True. In a future world, we will hopefully be able to essentially download built versions of these dependencies on your system architecture for your version of the compiler, so it's very fast. That's a problem that's being worked on actively. So hopefully a year from now, OCaml development is much easier to get started with. Okay, spit me out. Dune Messiah. The Dune Messiah will save us. Let's listen to the Dune Messiah's voice. Let's hear his lovely, angelic voice telling us to work with OCaml. Come learn OCaml with me today. Streaming tools, overlays. Edit. We all ready to hear his beautiful voice? Where's it at? It's so good. Okay, we're jumping back in here. All right, I'm gonna turn off the music and stream elements again, and we're gonna jump back in. Okay, so running npm run init has just finished. Again, that will probably take a couple minutes. What's gonna happen is OCaml is gonna go out and basically pull down all the dependencies and compile each dependency with the version of the compiler that we're using for this project, that being 5.1.1 in this instance. That's why this takes so long on the first go. So you'll see that we get this command spit out, eval opam-env. So let's copy that and throw that in our terminal. Again, this is just gonna bootstrap our environment variable, so we are working with our version of the compiler scope to our project, basically. Some other stuff. Looks like Kyle, you can cut this bit here. Okay. So next, let's go look at the next bit of instructions. So next up is going to be npm run build. So let's go ahead and copy that and run it. So we'll say npm run build. That looks like it went successfully. So what happened here is under the covers, npm called opam exec dune build. Opam is invoking Dune for us. Dune is OCaml's build tool. This is what's going to compile all of our artifacts for us and compile our OCaml or reason to JavaScript. So now that that's done, I believe the next step will be npm run serve. So let's see this. Drop that in there. We'll allow that. And there we go. Welcome to my app. We have a successful running Melange app. So next up is installing Visual Code extensions, or our editor tools. If you're using VS Code, you can go ahead and search for the OCaml platform extension. This is going to install your language server and formatting. Since I'm using NeoVim, we are going to have to do a slightly different workflow here. So if we kill this, we're going to say opam install OCaml LSP server and OCaml format. This will be the last step to getting started. Once these dependencies are installed, or if you're in VS Code and you have the platform extension installed and these settings set, we'll be ready to move on to the first chapter, building our counter component. That will be in video 2, and I'll catch you there. Okay, so I'll just add a marker, video 1, done. we'll come back here. Let me go ahead and install this stuff. Yeah, exactly, John. And let's get the music playing again until this is ready. These next two videos should go way more quickly and be way more interesting to watch than what I just did there. Oh, I have a pull request open to this repo to stop this. Let's go look at that real quick. D bundles. You can use filters on messages, so perhaps. All right, what is my initial message here? This tool is an alternative, and they're suggesting to change the wording to so let me take that, and then I have this pull request cloned locally. So let's go fix that real quick. Did I not do that on this laptop? I guess I didn't. Well, we can just edit the file directly on here. Edit file. And they're suggesting we change it to something like this is such an annoying message. I don't like that there's even a post install script. So let's say if you so the thing I want to this PR is trying to fix, chat, is if you look at this output right here, this is confusing because this doesn't count. Like, this isn't for us. It's not an alternative. If you want to use OCP, we'll copy that, indent from within Vim or Emacs directly. come back to here. Requires additional to install a package. If you want to use OCP indent from within Emacs or Vim directly, oh wait, I've fucked up all of this formatting. Okay, so we're just gonna drop that on one line then. We don't need to do this, so let's delete that. That goes back to there, that goes back to there. If you want to use OCP indent from within Emacs or Vim directly, so let's say if you are seeing this message as a result of installing OCaml format, is it OCaml format? What is the dependency name? OCaml format, one word. You may ignore the following instructions. If you want to use OCP indent from within Emacs or Vim directly, we'll add just an extra reminder. If you're not intending to use OCaml or OCP indent directly, so let's maybe we copy this down here and we put it there. Seeing this message as well as installing OCaml format, you may ignore the above instructions. And continue using your existing LSP and formatting configuration. Does that sound good, chat? That seems like a reasonable message, right? All right, let's commit change. I've updated the message to preview Let's get a re-request. All right, cool. Being the change we want to see in the world here. All right, let's pause the music. Oops. All right, and let's throw a marker in. And this time let's make sure we have our editor set up first before we have stumbles in our video. Let's make sure I can go in here. I can see this. I can get hover docs. Great. Okay. / marker video to chapter 1 counter. Take a sip of coffee. Okay. Welcome back to our series on Melange for React developers. This is the second video in this series. We're going to be covering chapter 1, counter. In our last video, we covered how to install the OCaml toolchain, get set up for this book. You can catch that at the link below. So in this video, we're going to be covering the counter chapter. So let's read about that. So the summary of the chapter is we're going to build an app that can be incremented or decremented, and we're going to learn about modules, the option type, we're going to learn about react.string, the pipe last operator, function chaining, and switch expressions. So without further ado, let's jump into counter. We're going to build the classic front-end starter app, the counter, using Reason React. If you've already installed the starter project, you can run the project now. Go to the root directory of your Melange for React devs template project and run npm watch to start the Melange compiler in watch mode. In another terminal window, start the Vite dev server by running npm run serve. As a side effect, it will open a browser tab. So the reason we want to do this is npm run watch is going to run OCaml's build tool Dune in one process, and that's going to watch our OCaml and Reason ML files for changes. And then npm run serve is going to run our JavaScript dev server. So the flow of code here is we're going to go and edit our OCaml and Reason ML files. Behind the covers, Dune in watch mode is going to see changes to that, and then it's going to use Melange to compile our Melange and OCaml and Reason code to JavaScript. Then Vite will see that JavaScript was compiled and changed, and then we'll refresh our dev server. So let's run both of these. So we're going to make a new window here, and let's decrease the size. In the first window, we're going to run npm. Actually, we need to get a Nix shell here. So now we should have node. Perfect. So let's say npm run watch. Okay, cool. Dune is now watching for file system changes. And let's open our second dev server, and we're going to run. We have to load up our dependencies. Great. npm run serve. Now this should open a browser. Yep. Okay, so we have a simple web app here. Let's jump back to the instructions. Open index.re and you'll see this code. Module app equals this React component thing with a function called make that returns a div and a React string that says welcome to my app. This is just about the simplest component you can make, but through it we can start to see some of the key differences of developing with Reason React. All components must be inside a module. The make function renders the component and returns a React element. We must decorate the make function with the React component attribute. In JSX, we must wrap strings with calls to React.string. Let's go over these differences in more detail. Components are modules. In the example above, a new module named app is defined. OCaml's modules are somewhat like JavaScript modules, with one notable difference being that there can be multiple modules inside a single file. For now, you just need to know that all components in Reason React are modules, and the name of the component comes from the name of the module, the make function. The make function has a function signature type of unit to react.element, meaning it takes parens, aka the unit, as the only argument and returns an object of type react.element. You'll need to decorate make with the attribute at react.component. We'll go into the details later, but for now, let's just say that React component is there to reduce boilerplate and make our code more readable and easier to understand. Wrapping strings with react.string. Unlike in normal React, we must wrap strings inside function calls to convert them to react.element type. This is exactly what react.string function does. If you hover it over it, you'll see that it displays the type string to react element. Using the app component. A little bit further down, we make use of the app component. We have let node is react dom.querySelector for the root, and then we're going to pattern match a node. If we get no value, we're going to log to the JS console, fail to start React, couldn't find the root element. If we do find the React root or the DOM root, we're going to say root equals react dom.client.create root, react dom.client render the root our app. So this should feel very similar to how we bootstrap our React apps in TypeScript and JavaScript. React.querySelectorRoot returns a option DOM element, meaning that if it doesn't find the element, it returns none. And if it does find the element, it returns some DOM element. That is, the element wrapped in the sum constructor. The switch expression allows you to succinctly express if node is none, log an error message. Otherwise, if node is some DOM element, render the app component to the DOM. We'll talk more about the option in the Celsius converter chapter. The counter component. Let's create a counter component by creating a new file, counter.re, with the following contents. So let's go make that file. So let's launch into Vim and we'll say counter.re. We'll save that, make the file, go into there. Let's go grab the code, copy to clipboard, paste that in and save. Okay. This is a component with a single useState hook. It should look fairly familiar if you know about hooks in React. Note that we didn't need to manually define a module for counter because all of the source files in OCaml are automatically modules, with the name of the module being the same as the name of the file. Now, let's modify app so that it uses our new counter component. So let's go to app. And in here, app, instead of rendering this v1, we are going to instead, change this, and we are going to render our counter. We'll save that, jump back to our instructions. Okay, that looks good. The pipe last operator. To display the number of the counter, we wrote React string and passed int toString of the counter value, which converts an integer to a string and then converts that string to a React element. In OCaml, there's a way to apply a sequence of operations over some data so that it can be read from left to right. This uses the pipe last operator, which is useful for chaining functional calls. So we're going to take counter, we're going to pipe that into string. So this will turn our integer value to a string, and then we will take that string value and pipe it into React string. So let's copy this. And is that already in the code? It does not look like it. Where did we write that? I don't see that. Let's go jump into our file again. It looks like the span is here. Am I just missing that in the code example? Maybe not. So that might be some feedback for the author. So let's jump in here and let's go back to our counter component. And in here, oh, right here's the part we need to change. So we are going to change this to instead be counter, which is an integer, and we're going to pipe that into int.toString, and then we'll pipe that into react.string. And we can now delete that bit there, and that should be completely equivalent. Great. Let's add a bit of styling to the root element of counter. Okay, unlike in React, the style prop in Reason React doesn't take a generic object. Instead, it takes an object of type React DOM.style that is created by calling React DOM.style.make. This isn't a sustainable way to style our app. Later, we'll see how to style using CSS classes. So let's copy this div and replace our div. So we'll come up here and we'll take this and we'll replace it, and we can format. Cool. So we're going to add some padding, we're going to make it flex, and we're going to give it a gap of 1em. Awesome. Jumping back over. Congratulations, you've created your first Reason React app and component. In future chapters, we'll create more complex and interesting components. Let's actually see how this runs in our browser, because this should be in our browser if I am not mistaken. What was our port? We're on port 5173, so let's open that and see what our app looks like. Okay, so here's our app, and look at that, chat. We've got a working counter. I believe we have some exercises yet. So here was the overview of what we covered in this video and chapter: how to create and run a basic Reason React app. Reason React components are also modules. OCaml has an option type whose value can be either none or some value. The pipe last operator is an alternative way to invoke functions that enables easy chaining of function calls. And we also learned how to use styles in Reason React. So what happens if you try to remove the none branch of the switch node expression in index.re? Well, my prediction is that we will get a type error. So let's go try that. Over here, and if we remove this, yep, error warning. This pattern matching is not exhaustive. Here's an example of a case that is not matched none. Cool, so OCaml's and Reason ML's type system is going to enforce when we do pattern matching that we cover all of the possible cases that a value can be. So let's jump back to our exercises. Removing the none variance will result in a compilation error. Basically, the compiler is telling you to handle the none case if you want to ship your app. This is part of what makes OCaml such a type-safe language. Exercise 2. What happens if you rename the event variable inside the button callback to event? I'm going to guess that we're going to get a warning about a unused variable. So let's remove that. Yep, unused variable EVT. And let's add that back in. Let's look at the solution. By default, OCaml wants you to use all the variables you declare unless they begin with underscore. So that should feel very familiar if you're coming from TypeScript, JavaScript, and React. Comment out the React component attribute in counter.re. What happens? Ooh. I believe we will probably get some type errors somewhere. Did that say in the counter? Yes. So let's go comment this out. So far nothing. Let's see our console output. Here we go. Unbound variable counter.makeProps. So what this is really doing for us when we put this annotation on it is it's saying, hey, Melange, when you compile my code, I want you to take this make function and add additional code to it at compilation time to make this a proper React component. So let's see what the author says about this. Commenting out the React component attribute in our counter.re will trigger a compilation error in index.re at the place where counter component was used. Yep. For now, don't worry about what counter.makeProps is or where it came from. Just remember that you need the React component attribute above your make function if you want your component to be usable in JSX. This is a very common newbie mistake. See the PPX chapter for more details. Awesome. Well, that is the end of chapter 2. Next video, we're going to cover I guess this was chapter 1, excuse me. Next time, we're going to cover chapter 2, numeric types. Okay, marker, video 2, done. And we're just going to roll right into this, and this is going to be the last one we're going to do today, because I feel like writing Gleam now. Welcome back to our video series on Melange for React devs. In this video, we're going to be covering chapter 2, numeric types. In the last chapter, we covered building our first Melange app and building a simple counter component. So be sure to check that out before you watch this video. But moving forward in this chapter, we're going to learn how to use Melange Playground to explore OCaml's numeric types. We're going to learn about ints, floats, the playground, how to share snippets, our comparison operators, arithmetic operators, and widgets in the playground. So let's dive in. Numeric types. OCaml's numeric types work differently than in JavaScript. The first thing you might notice is that OCaml makes a clear and hard distinction between integer and float types. For example, let foo equals 42. This is an integer. Let bar equal 42.1. This is a float, and we can log those out using js.log. Note that you didn't have to write the type yourself. OCaml is able to infer the types from the literals. This would also work. Let foo being typed as a int 42, and here we declare bar as a float. So Melange Playground. Melange Playground is an interactive environment for running OCaml code and seeing its output. Paste this code into the source editor on the left side. So let's open up Melange Playground. And let's grab our code here. And we'll get rid of this old stuff I had in there. And we'll paste in the new code. And we are not in OCaml. This is reason syntax. So let's click reason. In fact, there we go. And on the right side, we'll see what this reason code compiles to in JavaScript. So we see that we have var foo equals 42, var bar 42.1, and we have 2 log statements on that. In the bottom right panel, you can see the console output, which should be 42 and 42.1. Do we see that? Why don't we see that? Let's try making a change quick, because maybe it's because we pasted it. Oh. Interesting that we're not seeing that happen. Let's try this. So maybe the console is potentially broken right now. So let's jump back in, but we can assume that we would typically see our output right there. And back to our numeric types. In the top right panel, you can see JavaScript generated by the Melange compiler. Yep. Note that console.log invocations are giving constants instead of the variables. That's a nifty optimization done by Melange. Another sweet feature is that you can hover over the variables and see their types. Try it out. You'll see that foo has type int while bar has type float. The problems pane in the bottom left corner shows error messages when appropriate. At the moment, it shows no problems. Try type annotating bar with int. All right, so let's check out the type inference and causing a problem. So if we hover this, we see it's an int. If we hover this, we see it's a float. And now let's tell the compiler that this is actually an int. So now we get a type problem, which we see show up, sure enough, down in the problems pane. This expression has type float, but an expression was expected of type int. Cool. Sharing code snippets. Melange Playground is also an excellent way to share OCaml code snippets with your friends. As you type in the source editor, it will store your code in the code query string parameter of the URL. For example, here's a link to the snippet we started with. Sweet. So we should be able to come up and click this share button, and that will give us a link that we can share with people. Comparison operators. In Melange Playground, change your code to this, js.log foo equals bar. You'll get a compiler error for the last line that says, this expression has a type float, but an expression was expected of type int. So let's go ahead and try that. Say equal bar. We'll delete that line. And sure enough, we get the compiler error. Unlike JavaScript, there are no implicit conversions in OCaml. Therefore, you cannot expect to compare an integer and a float together unless you convert one of the values so that both values have the same type. To make the last line compile, you can change it to js.log equals foo equals int of float bar. Another way to fix the last line is to convert foo from an int to a float. Cool. Okay, this all makes sense. Arithmetic operators. What about addition? From what you've already seen, you can probably guess that js.log 42 plus 16.0 won't compile. However, you may be surprised to discover that js.log 42 plus 16.0 also won't compile. That's because OCaml uses separate arithmetic operators for floats. What will compile is this, js.log 42.0 plus dot 16.0. This prints 58. Here are some examples of other arithmetic operators. Try them out in the playground. Let's copy this. We can see we have minus plus or minus dot, asterisk dot, and slash dot. Let's go drop these in here. And, oh, we've got a barking dog. 1 second, chat. And we can see now that the console wants to work for us, and we see the output of 60, 396, and 11. And here we can see the compiled JavaScript. Notice that all float arithmetic operators have the dot period, just like float literals. They're just number. Underneath the covers, foo and bar are both instances of JavaScript's number type. If we were to do js.log js.type of foo, it's going to print number. Refer to the Melange docs for a complete rundown of how OCaml types get translated to JavaScript types. Widgets in the playground. Melange Playground can also render Reason React components. Click the Live button next to the JavaScript output. Now paste in the code to render the counter component from the previous chapter. One second, Justine's home. Kyle, you can clip this real quick while I tell her that I'm recording something. Hey, I'm recording a video. So.
Oh, let's not go get Dad.
Yeah, I already told him. It's good.
Wait, have they eaten?
No. So let's take our code and go to Melange Playground, and we'll click Live. And then we'll paste in our code from the last chapter. And look at that. We have our counter component rendered in the live view. Nice. Note that we explicitly defined a module for the counter component this time because we can't use multiple files in the Melange Playground. Let's make the counter look a little bit more impressive. Add a new module called styles, which contains all the styles we want to use. So let's copy this, and let's go ahead and put this in our playground. There's our styles module. And then update the JSX in our make function to use the styles object in styles. So we can take that, and that will be our counter component. And we'll come down here and we'll grab that, and I believe we just replaced this. And look at that, we have fancy new buttons. Nice. Here's the playground link for the fully styled counter component. Woot, you are now empowered to use numbers in your OCaml programs. Just a recap of what we covered. Integer and floats are separate types in OCaml, but both translate to JavaScript's number type once your program is compiled. Comparison operators expect the values on both sides to be the same type. Integer arithmetic operators are the same as JavaScript, but float arithmetic operators are different. They end with period and only accept floats as inputs. Melange Playground is a great way to play around with short OCaml programs and has many helpful features, including displaying console output, displaying compiled JavaScript output, displaying error messages when our code isn't compiling, giving us type hints, giving us snippets we can share, and rendering live recent React components. So we have some more exercises. Convert the counter component we created in the previous chapter to use floats instead of integers. Make the minus button decrement by 0.5 and the plus button increment by 1.5. So let's jump into the playground and do that exercise. We're gonna come in here, we'll bump the font size up. Let's collapse this panel. So we need to first convert our counter component to an int, or excuse me, from an int to a float. So we can do that. Rather than using 0, we'll use 0.0, which now we have some type errors here. We'll see that this expression has type float, but an expression was expected of type int. So let's go ahead and fix this, and we'll say we need to do minus dot, and we'll do 1.0 to start. And then now we have the next type error, and this is how you can see the compiler guiding us to solving our problems and being our friend here. So this expression is type float, but an expression was expected of type int. So rather than float to or int to string, we'll do float dot to string. Great, fix that type error. And now down here, this expression has type float. Again, like above, we need to change this to a float. I would have expected that to work here. So why is this upset now? Right, because we didn't use the dot operator. There we go. Recall that we have to use specific float arithmetic operators. Excellent. So the second bit of this problem is going to be changing the amount. We're going to decrement by 0.5 and increment by 1.5. So when we decrement, we'll say this is going to be 0.5. And when we increment, this will be 1.5. And look at that. There we go. Let's look at the solution. Yep, going to look pretty much identical to what we just did. Add an int64 value to your program in the launch playground. Let baz equal that giant number. Note the use of the underscore to make the larger number more readable. What is the JavaScript representation of int64? So let's take this and we will come over here and we'll just clear this out for now. We'll drop that in. We get this number. If I had to guess, a int64 will probably still be a JavaScript number type, because I believe the JavaScript number type is itself a 64-bit integer, but we can use js.typeof baz. And does that give us any output here? The console is not playing nice for us today. Let's go ahead and refresh and see if that helps us. We get a object. So maybe this is actually going to be a big int. Let's find out. JavaScript number type doesn't have enough precision to represent int64 values. They're instead represented by an array of two numbers, high and low, where high is signed and low is unsigned. Interesting. How do you add two int64 values? Well, let's find out. Let's take this and we'll add, we'll call this, oh no, did this freeze? It did freeze. Oh no. All right, Kyle, you can cut a bunch of this. Wow, this is truly struggling. What is happening? Did this like just break? Is there a redeploy happening? There we go. All right, so let's come back here and we're just gonna grab that code. It's like my actual like browser session is borked. Wow, I've never seen this happen with Milan's Playground, and I use this thing all the time. So I guess let's just close. Right? It's definitely like caching something, right? Because like this works in incognito. There's nothing in storage. Weird. All right, well, we're just gonna grab this and we're gonna go to an incognito tab and we're just gonna do the same thing. Okay. All right, I'm just gonna go back here. So exercise 2, add an int64 value to your program in Milan's Playground. Let baz equals this giant number, js.log baz. Note the use of underscores to make the larger number more readable. What is the JavaScript representation of int64? So if we go look in the playground, we see that this gets logged out as an array with 2 numbers in it, which must be string. We see 9 and then this giant number over here. JavaScript's number type doesn't have enough precision to represent int64 values. They're instead represented by an array of 2 numbers, high and low, where high is signed, low is unsigned. So how do you add to int64 values? So let's jump back to the playground and let's make another value here. We'll dump that in and we'll change this to bar and we'll say this will be, let's just say 39. And if we want to add these two, we know their types are int64, right? But we haven't learned about any sort of int64 operator. If we try to add them together with just the normal operator, we're going to get a type error because that only works with normal ints, right? This expression is type int64, but an expression was expected of type int. We've seen already also that we have modules for working with other types like float before. Remember we've seen float to string. So let's see if we have an int64 module. So we can maybe say int64 dot, let's see if we can do add, baz, and bar. And that seems to work. Great. And if we go look, we get this camel int64 add that does what we would expect. Let's see if that is the solution. Take a look at the standard libraries in 64 module, solution, boom, there we go. Well, this is the end of the second chapter and our third video in the series. Tune in next time where we are going to be covering the Celsius converter chapter. Okay, we will do 2 more chapters tomorrow. Let's get back to listening to music and get to Gleam. Marker and that's so weird about the playground. I'm gonna have to send that to the Melange team. Let's pull up the Gleam docs. Let's just open the standard library because we always want that open. Bump that over, switch over to Gleam. There we go. I'm gonna go throw my coffee mug on the charger real quick, chat, and grab some water because my mouth is parched from that. Actually gonna run to the bathroom real quick too. All right. I'll just ping Dave now and let him know it's an emergency. Yeah, stat. Hit his pager duty. Melange user. I wonder who that was. Okay, so let's jump back into Gleam. So yesterday we got to a point where this should still be building. And if we do Gleam run, this is probably going to spit out a token that I'm going to have to invalidate pretty much immediately. 1 second. So if we do Gleam run, boom, boom. Look at that, chat. So good. We just got an access token. All right, let's go invalidate this so y'all can't hijack my Twitch bot. Okay, that's invalidated, but I'm actually going to go grab a fresh token so I can use this. So I am going to blur my screen quickly. God, this is so convenient. This is so much easier than the process I was doing before. Boom. Save that. And then we'll grab the refresh token. Cool, and then we'll go update our environment variables file. Export access token equals this guy right here. I did not, Alice. All right. 1 second, chat. Almost ready again. I think I do need to fix that. I think Meta found a problem with my... I think Leo removed a function and we need to update that at some point. So maybe we'll do that later this week. Or if Meta, you want to fix that on your stream, I don't care. I'm still blurred. Let me reset and clear my console. Okay, cool. So I think the problem in that Serde for reference, John, we built an S expression parser for this. Yeah, I don't think I tracked any location here. No. Nope. But I think that this function right here needs changed. I just can't figure out how to set the start location for a Lex buff. I started looking into this a little bit last night, Meta, and in the Riot Discord for Surday, Leo linked this pull request, which is going to have some probably extra information. So that'll probably explain how to fix that. Said Lex. Let's see if we can figure this out with Alice real quick. So said Lexing, type Lex buff. I mean, if Alice can't figure it out, I'm almost certainly not going to be able to figure it out. Can you use this Lexing position thing? I actually don't know how this works. So because it automatically updates on white space, but if I'm Lexing, yeah, I'm not sure. But so I don't get completely derailed from Gleam, we're gonna come back over here and we'll come into Vim. Nice. Okay. So we now want to go to our auth token fetcher, and we need a way to pass in the redirect URI. So we also don't need this reply to on the state, I realized. Do that. What are we listening to? What is Apple Music doing here? All right, we can listen to Mac Miller. And then our warning. Okay, that looks good. Oops, I guess we need none. So we'll need a client, and we need a potential redirect URI, which will be a silly us. We just removed this. Type option, and I know we're going to bring in some. This will be some URI. So let's grab type. Oh, right, not some. I'm dumb. That's an option. And then we also want port, which will go before that. Port will be a option of int. Okay. And we'll do option dot unwrap. We need to pass in redirect URI, which will be a option of URI. And then we need a port, which will be a option of int. And then for this, we'll say redirect. In fact, can we make this a const? Const default. Let's just say const x equals, I'm assuming this won't work because it's an expression, but parse, yeah, we can't. So let's say redirect URI will equal option dot unwrap and this will be URI dot parse. In fact, we can just do this. This is fine. This will be default redirect URI, and this will equal URI dot parse redirect. Or how does that work? That's not a full. Let me look at the redirect server quick. We map it to string. Ah. Right. The question is then, so this will be default redirect URI, and this will be redirect URI. Yeah. Or actually, that's not what we want. What is the option module? Because we have to pass an option to the constructor. So do we make the default? Do we want the token fetcher to deal with the default, or do we want the redirect server to deal with the default? Because we handled that there. Yeah, actually this is fine. We don't need this. We'll come in here, and this doesn't need to be that. We can just pass through the redirect URI and the port. Expected type int. Oh, right, the port comes first. Okay. That looks good there. Good. We are we have OAuth working. We have a nice little library utility to go fetch OAuth tokens, and that's working super nicely. So now we're just going through and kind of cleaning up some of this. So let's generate. We need to generate our random bits next. So that's probably going to be in like bytes builder, maybe. How do we do this in OCaml? OCaml playlist transfer. When we get the random bits, how do I do that? We just do random bits. Does Erlang have a way to get random bits? Probably not. Let's see here. Packages.gleam.run random. Random number generator. So you can get a random bit array. Okay, so if we get a bit array, we can two-string it. All right, let's do that. So we'll add that package. This experience we're about to have right now is one of the reasons why I think Gleam is a better first functional programming language than OCaml, because we can just come in and say Gleam add PRNG. Boom. Make sure everything builds. Right, that's fine. So in here we can bring in, we can import PRNG/random, I think. Yeah, that should work. So we should be able to do this and then come down here and let csurf state equals PRNG, or it'd be random dot bit array, and we'll two-string that. Oh, it returns a generator. I think the generator is the function. So this will be random bit generator. And then we can say let csurf state equals random bit generator. And we'll pass that into bit array. Bit array. Come back down here, and this will be bit array dot toString. And then csurf state will be this guy right here. Paste that in. And we got to go back to here. The token fetcher now takes, we'll do none, none. This is being called as a function, but it's type generator. You using Copilot or something like that? I am not using Copilot. Is there a generate function? Getting values out of a generator. To actually get a value out of a generator, you can use the step function. It takes a generator and a seed. Interesting. So if we go look at seed, we'll just get a random seed. All right, so we have to bring in seed too. So let's go forward here, and we're gonna have to get prng slash seed, and then we'll come down to our code, and this will be what is the function again? We need step. So we'll say random dot bit array, and we'll pipe that into random dot step, and that needs our seed dot random, and then that gets piped into bit array dot toString. And we can come over here and we can delete that. So that should be good right there. Oh, it takes the type. Okay. So we can also come in here and we can grab the pair package. And we can come down here and we can say pair dot first, right? First is the function. Yeah, great. Ooh, this might even be map first. Oh, it still returns. Yep, that's fine. All right, so let's try building again. Ah, that gives us a result. Okay, so we can say let assert okay, and we'll just let this crash if this didn't work. There we go. Cool. So I'm actually going to come down here and we're just going to respond so I don't leak anything sensitive. Oh, this actually needs, that's an access token still. So in our main, we just don't want this bit. Gleam build. Okay. And here we can, oops. What was that build error about? Oh, that's in our main. So we can just come in here and do that. So now chat, I want to log our random state. Let's bring in IO. IO, and then let's do io.debug csurf state. And let's see what that gives us. Gleam build, great. Gleam run. Cool. There we have some random state. Which I'm not sure if that, we got invalid csurf state. Okay, that's a good start. We might have foobar hard-coded in our redirect server. No. So we hit, you can delete this. I wonder if it's because it's like Unicode or something that it's getting messed up. So what does it say our code is here? Let's go back and change how we're generating our... Let's do random string, I guess. What? What does it think the state of this is? String seed. I guess that doesn't... Okay, that's fine. All right, let's try this now. We'll kill the server. And now let's do Gleam run. So it's still generating strings that we can't... What if we do then URL percent encode? Or that's URI. Let's try that. Invalid C search state. What up, Billy? We could encode it to base 64. Oh, base 16 versus base 64. Whatever, we'll just go to base 64 for our code generation. So we'll do... Is that why this is happening, chat? So if we go back to generating random bits, we generate a random bit array. We get the bit array. This will be a result. Say result.map, and then we'll do bit array, and we'll do base 64 encode. Do that. Maybe that's... Oh, it was the toString that returned a result. And what does this return? Bit array URL encode padding. Do we want padding? Probably. And that gives us a string. All right, so if we run this now, we get a nice, right, because we're gonna have to base 64 decode it. Or no, we should get that right back, shouldn't we? What is happening? Our state is foobar. Well, that's the frickin' problem. Somewhere we have foobar still hard-coded. Stupid. So that means we can do bit array, toString. And this will be assert. Okay. Okay. I guess we just grep for foobar. Well, that's not the problem. Token fetcher.gleam. Oh, we have to build the udirect.
Are you done with your video?
What?
You done with your video?
Yeah.
Nice.
What's up?
Do you need more coffee?
Yes, please.
Okay.
Thank you, boo.
I gotta take a call though, so I'll shut this. Come on.
Okay.
Oh, okay.
So we give. Oh, we open this. So let's make a function to build the redirect URI. So we'll say, just write function new redirect URI, and this will take all right, so we're not gonna send the port because that can be part of, the port is part of the redirect URI. So let's fix that. Okay, I see what code editor are you using? I am using NeoVim. And welcome to chat, Nuber1. Appreciate you hanging out with us this morning. How do you spell that? NeoVim. NeoVim. Do I have that command? There we go. Okay. So the redirect server is going to get, let's see here, what do you get? Redirect URI. And that is going to be the fourth argument, or no, mailbox port. So we don't need port there. So we can go delete that. And we can move that from the state. And then we'll have an error down here. And we want to get the let port is going to be URI dot, does this have a port? It'll be state dot redirect URI dot port. In fact, we'll need to do option dot map the redirect URL. And we're going to do a function that gets the URI. And we'll return URI.port. And then we'll do a dot unwrap of 3000. Oh, right, we then go option dot unwrap 3000. Oh. Okay, sure. I guess we can put this here then. Option. This is actually not a map. This needs to be bind. Then there we go. And this will be port. And we can delete, put that there, do that. Cool. That looks good to me. We can come back over here, and now the constructor it's up at the top. New takes a mailbox and then a redirect URI. Okay. In fact, I don't know. I don't think this should be an option. Which makes this better, right? Because now we can say dot port, which is the option, and we can just call unwrap on that. Dot unwrap u, and this will be. Oh wait. It's not an option anymore. We just say redirect URI. This will be URI.toString server.redirect URI. Yeah, and then we have to do this down here. This will be dot port. We can take this And we can put that there with a comma, delete these. Go to the beginning of the line, delete those. Okay, that works there. I wonder if we should set the port. That's probably fine. One last question. Are you using OBS Studio for streaming software? Yep. That's exactly what I'm using. So if they don't give us a redirect URI, this will be an option of URI, and it's going to return a URI. And we'll say case that URI is sum, we will just return URI. And in the case that it's none, we will do this will be csurf state, which is a bit array. No, it's a string. And then we in fact, we could just take the token fetcher. And we'll get, we need the client ID. So we'll say let client ID equals token fetcher. I will actually have to do client.client ID. We'll do token fetcher dot client. We'll have to bring that in probably. Oh no, we have the client, so that's okay. And then we need to get the redirect URI, and that'll be option dot unwrap, and that'll be token fetcher dot redirect URI, and the default will be an empty. Can I not just make an empty one? Let's say const empty URI equals URI. Let's just grab this. In fact, we can go to our extended, and we'll add URI extended.gleam. Okay, and I want to see, we have like a new, don't we? It's a pretty common convention, yeah. So let's go back to that extended URI, and we'll do import Gleam /URI, and we'll get the type URI. We'll also get the constructor URI, and we'll say pub function new is going to return a URI, and in here, just paste this thing, and we'll record a little macro. This will be none down the beginning line. Then we'll but path is a string, so we'll just make that empty. And then we can say set scheme, because none of these are on there. All right, I'm gonna, oh, what up, Colchis? Thank you for the resubscription. Good morning. Super appreciate that. Always appreciate the subscriptions, y'all. So I'm gonna get on a good song and just bang out these helper functions real quick. Winnie Marie, no barks. Hey, wanna go in timeout? Stop it. Wait, does this actually have a function on it? Is that... I don't see new in this package. It's not. LSP is just confused. Okay. Thank you for the follow, Quad Ublek. I will be chatting again here in a moment. I'm working on knocking out some quick code I want to concentrate on. Const. I like Twitch. Am I welcome? You are very welcome here.
Here you go.
Thank you.
Also, does this look okay?
Yes.
So, interview will be here up.
Yeah.
Yeah? Okay. Thanks. Appreciate you.
The fuck? My J key. The heck? My J key's like all fucked up. Where's my keyboard surgery? Hopefully I don't have to swap that switch. Also, what language are you using for this Twitch bot? Meta got it. This is Gleam. Yep. So Gleam is like Rust and Beam have a baby. Kind of, yeah. I would say Gleam is like if OCaml and Elixir had a baby and used Rust's syntax and also had the simplicity of Go. I have very positive impressions about Gleam so far. I really, really, really like it. God, my J key is not working. I'm gonna have to replace this switch. Oh my God, this is so annoying. Yeah, all right, I have to grab another key. 1 second, chat. Keyboard surgery. All right, let's find, not that one, that one's sticky. That sounds pretty good. Looks like I've used this one already, so we'll put that into a maybe pile. That feels and sounds pretty good. Also feels and sounds pretty good. All right, so we have some options here. This one. Okay. Yep, okay. We've got a new switch to replace. I'm gonna turn off the keyboard. We're gonna remove the old switch. Pull that out. I wonder what's going on with that. Hopefully it's not my circuit. That would be bad. We're gonna put the new switch in. Okay. We're gonna throw the keycap back on. And make sure that's in there. Power back on. Oh no, it's like hardly working. That one's even worse. Oh god. Not good, chat. Not good. I swear, if this is my circuit crapping out on me, about to have a real bad day. Let's just try throwing that in. All right, that feels better. So I must have just got... Okay, so let's throw the J key back on. All right, that feels so much better. Okay, we just got 2 unlucky switches in a row. That's weird. Okay. J key still feels weird. All right, maybe it's in my head. Oh, we need to map. Right. We do... This will be list.map. And then we'll do this. Incorrect arity, because we need to do in will be that. There we go. Nice. That's a very helpful function. Like, basically, to build a path, we're going to have consumers give a list of strings. So the input will be something like, let's do this. We're going to have to wrap up in a second, but it'll be like foo, and then this would be like an ID, right? So let's just say it's like 39. And it'll break this down and return a new URI with the path filled out as that. However, if someone comes in and decides to like prefix that, we're gonna trim it and do that for them, so it's super safe. Cool, I like that. I like it a lot. All right, what else do we need to do here? We can bang this out quick before I wrap up, because I do have to wrap up for my actual day job. Let's see here. We can set the port, we can set the query. Okay, and we'll just add a pub function set query, which will take a URI of URI and query params, which will be a list of a tuple of string, and we're going to return a URI. We're going to yoink u, paste that, and we'll say this is going to be query, and this will be let query equals query params. And we'll pipe that into URI dot query to string. And then we'll pipe that into sum. And then we can say query. Boom. In fact, we might even be able to go like URI dot URI query. Can we do this? Is that valid syntax? No. I thought we might be able to. All right. So that works there. And we can go use this in here. Now we'll say URI extended dot new, and oh my god, my J key is fucked. Whatever, we'll do this tomorrow. So let's write to do start here on Thursday. Oh my god, I have to fix this so bad. All right, chat, let's find somebody to raid. Thank you for hanging out. Super appreciate all of y'all. Who do we got going? Study time. Teach is going. Yeah, let's just raid Teach. We'll be back tomorrow, chat. Thank you.